So sometimes elimination is not as convenient as simply using substitution. Both are essential toolkits for your algebra toolbox. In this case, if we know that y is equal to x minus 35 and y is also equal to negative 4x, we have a situation where we have, and it's always useful to number your equations, one, two equations, and two unknowns, x and y. In this case, I could substitute 2 into 1 in this way by rewriting y equals x minus 35, but I also know that y is equal to negative 4x. So I'm going to substitute negative 4x in place of y. I always substitute into brackets even when they don't influence the calculation because it helps me avoid a wide variety of errors. So now I know negative 4x equals x minus 35. I have a case of one equation, one unknown, even though that unknown is showing up in multiple places. What I want to do at this point is to get all those places to be in the same place and get all my x's to one side, all my numbers to the other side. So to group all my x's together, I'm going to move this x across the equal sign by subtracting it from both sides. Then I would have negative 4x minus x would be negative 5x equals negative 35. And now division removes the coefficient from x, so I can divide by the coefficient on both sides to find that x is equal to 7. Once I have this, it's half of my solution, and I can go back and substitute it in. I would probably choose to substitute it here. Y is equal to negative 4 times x. So if I know y was always equal to negative 4 times x, but I know that x is equal to 7, I can substitute that in there like this. Y is equal to negative 4 multiplied by 7, and then I would have y is equal to negative 28. This is the other half of my solution. At the end of the day, I got to write this down as a point. Answer. Hurrah. So now let's take a look at one of the trickier problems where here I don't have one of my variables already isolated. Oh, actually I do. Y is isolated in this case. So I can actually substitute directly there. So let's go ahead and do that. All right. So I'm going to start by writing down the first equation. My first equation is 8x minus y equals 42. And now I'm going to substitute the second equation in for y. Notice here that substituting into brackets is essential. Minus, and then the entire contents of this equation here. Minus 4x minus 6 is exactly the same thing as y, I'm told there. So let's put that in place of y. Minus 4x minus 6 equals y. Here I have a negative and multiple. I need to distribute this negative in to simplify these terms. This negative basically just tells me flip the light switch for all the terms inside that bracket. So I can remove the brackets by saying 8x plus 4x minus plus 6, just noticing that I did something strange there. This is not y over here, of course. This is 42. It's still 42. I don't know why that became y over there. So that's still 42. Okay. So now 8x plus 4x plus 6 is equal to 42. Just collect like terms, 12x, and subtract 6 from both sides. 12x is equal to 42 minus 6, which is 36. 12 times some number equals 36. Well, I happen to know that 12 times 3 is equal to 36. So I'm not going to bother dividing both sides by 12. Well, you could do that, and that will give you 3. So x is equal to 3, and let's find out what y is. If I knew that 8x, but in this case 8 times 3, minus y is equal to 42, substituting this x in here as 3, then I would have 24 minus y equals 42. Subtract 24 from both sides will give me 18. And so y is negative 18. Yes, y is negative 18. Let's write out our inverse operations. We're not in that much of a hurry. So I subtract 24 from both sides. That gives me negative y is equal to 18. 42 minus 24 is 18. And then I divide both sides by -1 or multiply both sides by -1 to clear that -1. And I have y is equal to -18. So let's try that. 3, tab, -18. Submit the answer. Hurrah. All right. So this is solving linear systems algebraically. Any questions, hit me up by email or come find me.